When dealing with a 480 volts fire pump supplied from a 12,470 volts service and stepping it down, understanding the National Electrical Code, or NEC, requirements for protecting the secondary conductors is crucial. Specifically, we need to address the guidelines outlined in section 230.6 regarding service conductors installed under a building. Let's clarify whether mineral insulated, or MI, cable meets these criteria, and if not, what alternative solutions are available. The question is, does a MI cable meet the criteria for secondary conductors treated as service conductors as required by NEC 230.6? The answer is no. A MI cable does not fulfill these requirements. To understand why, let's delve into the NEC requirements for secondary conductors that are treated as service conductors. These conductors must adhere to specific standards to ensure safety and reliability. Firstly, they must be rated for 600 volts or higher. Secondly, they need to be enclosed in a raceway or cable assembly that offers physical protection against damage. Thirdly, the conductors must be protected against overcurrent by a main disconnecting means located in the service equipment. A MI cable falls short of meeting these requirements for a couple of reasons. Firstly, it is not typically rated for 600 volts. Secondly, its flexible metal sheath might not provide adequate physical protection as mandated by the code. Therefore, a MI cable is not a suitable choice for this application. Now, let's explore alternative methods that comply with NEC 230.6 for secondary conductors treated as service conductors. Several options provide the necessary protection and meet the code requirements. One option is rigid metal conduit. This provides exceptional physical protection and is well suited for high voltage applications. Another alternative is electrical metallic tubing, or EMT. This is a cost-effective option compared to rigid conduit while still providing good physical protection. Type MC cable is another possibility. This flexible cable features a metallic sheath that offers overcurrent protection and resistance to physical damage. Busway is also another option. This prefabricated electrical system provides a rigid housing for conductors and is suitable for high current applications. Now let's address the location of the fire pump. In this scenario, the fire pump is located in the penthouse. However, the location does not affect the requirements for protecting the secondary conductors. The same rules apply regardless of where the equipment is situated. Therefore, the penthouse location does not change the need to adhere to NEC 230.6. Considering the specific requirements for a 480 volts fire pump supplied from a 12,470 volts service, the recommended options for protecting the secondary conductors are rigid metal conduit or electrical metallic tubing. These raceways offer the necessary protection and comply with the requirements of NEC 230.6. By using these methods, compliance with the NEC can be ensured while providing a safe and reliable power supply for the fire pump system. Let's dive deeper into the specifics of each alternative to gain a more comprehensive understanding of their advantages and applications. Firstly, rigid metal conduit, often referred to as RMC, is a heavy-duty option known for its exceptional physical protection. RMC is typically made of galvanized steel or aluminum, providing excellent resistance to impact, corrosion, and other forms of damage. This makes it particularly suitable for environments where the conductors are exposed to harsh conditions or potential mechanical stress. RMC is installed using threaded fittings, creating a robust and secure raceway system. Its rigidity helps to prevent the conductors from being bent or crushed, ensuring the integrity of the electrical system. Due to its durability and protective qualities, RMC is often used in industrial settings, outdoor applications, and areas where there is a high risk of physical damage. Secondly, electrical metallic tubing, or EMT, is a lighter and more cost-effective alternative to RMC. EMT is made of steel or aluminum and is typically thinner than RMC. While it provides good physical protection, it is not as robust as rigid metal conduit. EMT is installed using fittings that are either compression type or set screw type, allowing for relatively easy installation. It is commonly used in commercial and residential buildings where the risk of physical damage is lower than in industrial settings. EMT is a versatile option that can be used in both exposed and concealed locations, providing a neat and organized appearance. Thirdly, Type NC cable is a flexible cable assembly that consists of insulated conductors encased in a metallic sheath. The metallic sheath provides physical protection to the conductors and also serves as an equipment grounding conductor. Type NC cable is available in various constructions, including those with an overall jacket for additional protection against moisture and corrosion. Its flexibility makes it easier to install in tight spaces or around obstacles. Type NC cable is commonly used in commercial and industrial applications for power, lighting, and control circuits. It is a popular choice for retrofit projects because it can be easily fished through existing walls and ceilings. Fourthly, busway is a prefabricated electrical distribution system that consists of a series of interconnected bus housed within a protective enclosure. Busways are designed to carry large amounts of current and are available in various sizes and configurations to meet different load requirements. They offer a rigid and secure housing for conductors, providing excellent physical protection and minimizing the risk of electrical faults. Busways are commonly used in industrial plants, data centers, and high-rise buildings where there is a need for a reliable and high-capacity power distribution system. They can be installed horizontally or vertically and can be easily expanded or reconfigured as needed. When selecting the appropriate method for protecting the secondary conductors of a fire pump, it is important to consider the specific requirements of the installation, including the environmental conditions, the risk of physical damage, and the electrical load. Consulting with a qualified electrical engineer or contractor is recommended to ensure that the selected method complies with the National Electrical Code and provides adequate protection for the conductors and the electrical system. In addition to the physical protection provided by the raceway or cable assembly, it is also important to ensure that the conductors are properly sized and protected against overcurrent. The overcurrent protection device, such as a circuit breaker or fuse, should be sized to protect the conductors from overheating and potential damage in the event of a fault or overload. The overcurrent protection device should be located in the service equipment, which is the main electrical panel that supplies power to the fire pump system. Regular inspection and maintenance of the electrical system are also essential to ensure its continued reliability and safety. This includes checking the condition of the conductors, raceways, and overcurrent protection devices, as well as testing the operation of the fire pump to verify that it is functioning properly. By following these guidelines and best practices, it is possible to provide a safe and reliable power supply for a 480 volts fire pump supplied from a 12,470 volts service while complying with the requirements of the National Electrical Code. Furthermore, it's important to consider the grounding and bonding requirements for the electrical system to ensure electrical safety and minimize the risk of electric shock. Grounding involves connecting the non-current carrying metal parts of the electrical system to the earth, providing a low impedance path for fault currents to flow back to the source. Bonding involves connecting all metal parts of the electrical system together to create an electrically continuous path, reducing the voltage potential between different metal parts. Proper grounding and bonding are essential for protecting people and equipment from electrical hazards. The National Electrical Code provides detailed requirements for grounding and bonding, which must be followed to ensure compliance and safety. In addition to the specific requirements for fire pump installations, it is also important to be aware of other relevant codes and standards that may apply. These may include local building codes, fire codes, and insurance requirements. Compliance with all applicable codes and standards is essential for ensuring the safety and reliability of the electrical system. Staying up to date on the latest codes and standards is also important, as they may be revised periodically to reflect new technologies and best practices. Continuing education and training are valuable for electrical professionals to stay informed and maintain their expertise. By staying informed and following best practices, electrical professionals can ensure that fire pump installations are safe, reliable, and compliant with all applicable codes and standards. The importance of proper design, installation, and maintenance cannot be overstated, as the safety of people and property depends on the proper functioning of the fire pump system. Furthermore, when designing and installing the electrical system for a fire pump, it's crucial to consider the potential for power outages and the need for a reliable backup power source. Fire pumps are essential for providing water to fire suppression systems during emergencies, and they must be able to operate even when the main power supply is interrupted. To ensure continuous operation during power outages, a standby generator or an uninterruptible power supply, or UPS, system can be installed to provide backup power to the fire pump. The standby generator should be sized to meet the full load requirements of the fire pump and other essential equipment. It should also be equipped with an automatic transfer switch, or ATS, that automatically switches the load from the main power supply to the generator in the event of a power outage. The UPS system provides a short-term backup power source that can bridge the gap between the loss of main power and the startup of the generator. It typically consists of batteries and an inverter that converts the battery power into alternating current, or AC power. The UPS system should be sized to provide enough power to keep the fire pump running until the generator starts up. In addition to the backup power source, it's also important to consider the reliability of the electrical distribution system that supplies power to the fire pump. The distribution system should be designed to minimize the risk of electrical faults and to provide multiple paths for power to reach the fire pump. This can be achieved by using redundant feeders, automatic transfer switches, and other reliability-enhancing measures. Regular testing and maintenance of the backup power system and the electrical distribution system are essential to ensure the continued reliability. This includes testing the generator, the UPS system, and the automatic transfer switches on a regular basis, as well as inspecting the conductors, raceways, and other components of the distribution system. By taking these steps, it's possible to provide a highly reliable power supply for the fire pump, ensuring that it will be able to operate when it is needed most. Furthermore, it is essential to ensure that all electrical equipment used in the fire pump system is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or Intertek, or ETL. Listing and labeling indicate that the equipment has been tested and certified to meet applicable safety standards. Using listed and labeled equipment helps to ensure that the equipment is safe to use and that it will perform as intended. It also helps to comply with the requirements of the National Electrical Code and other applicable codes and standards. In addition to listing and labeling, it's also important to ensure that the electrical equipment is properly installed and maintained. Improper installation or maintenance can compromise the safety and reliability of the equipment and can increase the risk of electrical hazards. Electrical equipment should be installed by qualified electrical professionals who are familiar with the applicable codes and standards. The equipment should be inspected regularly and maintained in accordance with the manufacturer's instructions. Any damaged or defective equipment should be repaired or replaced promptly. By following these guidelines, it's possible to ensure that the electrical equipment used in the fire pump system is safe, reliable, and compliant with all applicable codes and standards. The ultimate goal is to protect people and property from electrical hazards and to ensure that the fire pump system is able to operate effectively in the event of a fire. And remember, local requirements may apply and it is your responsibility to verify you are following all applicable codes.